Hey, this is Dexter. This video is about Trigonometric R-Formula. The diagram on the right shows a four-sided figure A, B, C, D. With AB to be equal to 3 cm, BC is equivalent to BD at 4 cm, and angle ABC is a right angle, angle DBC is X and acute angle. In part 1, show that the area of the figure A is equal to 6 cosine X plus 8 sine X. Next, express the area in the form r cosine X minus alpha, where r is positive and alpha is acute. In part 3, state the maximum area of the quadrilateral. Lastly, find the value of X for which the area is 7 square centimeters. This question is from Anderson Secondary 2021 Prelim for Additional Mathematics. Pause to give it a try, and when you're ready, keep watching. The area of the quadrilateral can be found by finding the area of triangle ABD in blue, as well as the area of triangle BCD in red. To find the area of triangles, we will need to apply the formula of half AB sine C, where A and B refer to the two sides of a triangle, and C is the angle between the two sides. Area of triangle ABD can therefore be found by having half by 3 by 4 by sine 90 minus X, where 3 is from AB, 4 from BD. The angle between these two sides is the angle ABD, and it will be 90 degrees minus X. Similarly, area of triangle BCD can be found by having half times 4 square times sine X, where 4 is from BD and another 4 from BC. The angle between these two sides will be X. Next, we apply the complementary angle formula, where sine 90 minus theta is equal to cosine theta. With that, our area A will be 6 cosine X plus 8 sine X. For part 2, we begin by having A to be equal to r cosine X minus alpha. We will now replace the left hand side to be 6 cosine X plus 8 sine X found earlier in part 1. For the right hand side, we will expand the R formula through the application of addition formula for cosine, giving us r cosine X cosine alpha plus r sine X sine alpha on the right hand side. Then we will compare the terms consisting of cosine X on both sides of the equation. We should tell that r cosine alpha is equal to 6 as our first equation. Similarly, comparing the terms consisting of sine X on both sides, we know that r sine alpha will be equal to 8 in our second equation. Knowing that tangent theta is equivalent to sine theta divided by cosine theta, we will now take the second equation and divide it by the first equation, giving us tangent alpha to be 8 over 6. Solving for alpha will give us 53.13. The second part of the R formula will involve the addition of squares of both equation 1 and 2. On the left, we will have r squared cos square alpha plus r squared sin square alpha, and on the right, the sum of 6 square and 8 square. We will now factor out r square. From the basic trigonometric identities, where sin square theta plus cosine square theta equal to 1, the sum of cosine square alpha and sin square alpha will therefore be 1. Solving for r will be positive 10. Replacing the values of alpha and r, A is found to be equal to 10 cosine X minus 53.1 degree in 1 decimal place. To find the max area, we will need the graph of cosine curve, which begin at a maximum of 1 when x is 0 degree, and intersect the x-axis at 90 degree before it reaches the minimum of -1 at 180 degree. It will next cut the x-axis again at 270 degree before ending its first period of 360 degree at the maximum of 1 again. Since the max of any cosine function is 1 as seen in the graph, we will now replace cosine of x minus 53.1 to be 1, and our max area will therefore be 10 square centimeters. For the last part, we will set the area A to be 7. Next, we will shift the constant to the right, and the basic angle alpha 2 can be found by having cosine inverse of 0.7. Just like any other solving of trigonometric equation, we will need the ASTC methods. Since cosine is positive in this equation, it will mean that this angle will be in either the first or fourth quadrant. We will also eliminate away the first quadrant, as X is an acute angle And should the angle be in the first quadrant, solving for x will give an obtuse angle after adding 53.1 degree. The angle must therefore be in the fourth quadrant. For x to be acute, the angle can only be moving downwards, implying that this angle will be negative alpha 2. We can now equate x minus 53.1 to be equal to negative alpha 2. And shifting the negative 53.1 to the right, we will solve for x to be 7.6 degree in one decimal place. Let's try another similar question for Trigonometric R-Formula. Given that 5 cosine theta minus away sine theta is defined for the range of theta from 0 to pi inclusive, using r cosine theta plus alpha, where r is positive and alpha is acute, solve 5 cosine theta minus away sine theta equal to 2. Hence, solve 5 cosine half theta minus sine half theta equal to 2. Lastly, find the largest and smallest values of 10 cosine theta minus away 2 sine theta bracket square and find its corresponding values of theta. This question is from CHIJ St. Nicholas Girls 2021 Prelim for Additional Mathematics. Pause to give it a try, and when you're ready, keep watching. We will apply the R formula by equating 5 cosine theta minus away sine theta to be equal to r cosine theta plus alpha. Expanding the right hand side using the addition formula for cosine, we will have r cosine theta cosine alpha minus away r sine theta sine alpha. By comparing the terms consisting cosine theta on both sides, we will have r cosine alpha to be equal to 5 as the first equation. Similarly, by comparing the terms involving sine theta on both sides, we will have r sine alpha to be equal to 1 as the second equation. Applying the formula where tangent theta is equal to sine theta divided by cosine theta, we will take the second equation and divide it by the first equation to give us tangent alpha to be equal to 0.2. Alpha is then calculated to be 0.197 radian. Next, we shall square both equations and add it, giving us r square cos square alpha plus r square sin square alpha on the left. Then, we factor out the common term of r square. From the basic trigonometric identities, the sum of cos square alpha and sin square alpha is equal to 1, leaving us with r to be positive square root of 26. Thus, 5 cosine theta minus away sine theta is equal to root 26 cosine of theta plus 0.19740. We will now set the result to be equal to 2. Then we will shift the root 26 to the right. Our basic angle alpha 2 will be cosine inverse of 2 divided by square root 26. To solve this trigonometric equation, we will apply the ASTC quadrant methods. We found earlier that cosine is positive, meaning that the angle can be found in only the first quadrant A or the fourth quadrant C. We will also eliminate away the fourth quadrant C, as solving for theta will be negative and it will be out of range as defined in the question. The angle must therefore be in the first quadrant A. For the angle to be within the range, it can only be moving upwards. And we will describe this angle as positive alpha 2. We can now equate theta plus 0.19740 to be equal to alpha 2. And shifting the constant to the right, we find that theta is 0.970 radian in 3 significant figures. For the next part of the question, we will need the equation from part 1, and compare it against the equation in part 2, we can tell that the only difference is that the angle is now half theta instead of 1 theta. We will now replace 1 theta to be half theta from the solution in part 1, and solving for theta will give the answer of 1.94 radian in 3 significant figures. To find the largest and smallest value, we will need the graph of cosine curve, which will start from the maximum of 1 at 0 radian. You will then go to the minimum of negative 1 at pi, before ending off the first period of 2 pi at the maximum of 1. From part 1, we will have 5 cosine theta minus away sine theta to be equal to square root of 26 multiplied by cosine theta plus 0.197. We will multiply by 2 to both sides of the equation, then we square both sides. From the question, 5 cosine theta minus away sine theta is only defined for the range of theta between 0 to pi inclusive, That means we will not be able to use the last two critical points. We will also eliminate away the first critical point of 0, 1 as solving for theta will be out of range from the question as well. Noting that the square of this expression will remove all negatives within it, we now replace the cosine function to be its minimum of -1. And evaluating this will give the largest value to be 104. This happens when an angle is equal to pi. Solving for theta will give us a value of 2.94 radian in 3 significant figures. As the smallest value of a square is always 0, we will use the coordinate of half pi, 0. And replacing the cosine function to be 0, we find that the smallest value is also 0. This happens when an angle is half pi. Solving for theta will give us a final answer of 1.37 radian in 3 significant figures. And that's the answer. Did you manage to get it right? I hope you've learned something again. Thanks for watching and see you in the next episode of Practical Math.